Hello, and welcome to Cornell Racing's Accumulator Inspection and Design Showcase. Over the next 10 minutes, we are going to be attempting to complete all items off of the Accumulator Technical Inspection Sheet. We develop our pre-charge board in-house. To ensure proper HV-LV separation, we have 5 millimeters on the board between each side, both labeled properly. I want to show the conformal coating on both sides of the board.
And then for reference, without conformal coating.
Each of our connections in our HV path are bolted connections using distorted thread lock nuts. For our ARG connections, we use M10 distorted thread lock nuts. In other various points on the HV path, we use ⅛28 distorted thread lock nuts and M5 distorted thread lock nuts. There is no soldering in our HV path.
Each pole of all of our segments is isolated from the internal walls by using a shroud around the maintenance plug receptacle. They're also isolated from the internal constraint walls that are vertical. The rest of the high current path is isolated from the segments by use of a polycarbonate plate rated to UL94V0. Also in our high current path is a fuse, which you can see here, isolated using Scotch 69 tape. With the design of our high current path, no tractive system wires can leave the accumulator without going through a closed airs. You can see the DC minus air is here, leading to our HVD, and our DC plus air is here, leading to our HVD.
With the use of our maintenance plugs, we can utilize keyed connections to make sure that no maintenance plug can be installed incorrectly. You can see on the maintenance plug side, there's a 180-degree keying denoted by these two sort of rectangular protrusions. We can install our maintenance plugs without requiring any tools. By hearing the click, we know that the maintenance plug is fully installed correctly. We're also unable to connect maintenance plugs incorrectly. This is the same maintenance plug I used last time on these two connections, and I will now try to connect them using these two connections. As you can see, with the same amount of force applied, the maintenance plug is unable to connect, and it can be disconnected without hearing a click.
Our battery pack is made of Energous modules, 1S6P. These modules are connected in series inside of our segment cases. Our segment cases are 3D printed plastic, but to ensure that they satisfy the UL94V0 requirement of rules, they're lined with these thin mica sheets. These mica sheets are then slid in the inside of the case, and the Energous modules are installed.
We only have one tractive system connector outside of our accumulator enclosure, and we made sure to purchase one with an interlock. We can see the 2-pin DTM inside of the pack here. When the HVD is disconnected using a multimeter, no beep means that it is not continuous. Now, when we install our HVD, we should expect a beep, meaning that the interlock is continuous. Just for safe measure, we can also show that now it is discontinuous.
We do not have any spare accumulators.
For charging, we use a Brusa NLG513 water-cooled charger. This is our charging part. On the underside is the Brusa. To make sure that we can't connect each of the leads in an improper configuration, you can see that there are two different ways in which the pins are configured and the type of pins. One contains pins, the other contains sockets. We can also show that both of our leads are orange. Thank you for spending the last few minutes with us. Please make sure, whenever working on high voltage, to wear your protection.
Remember, the dangers of not wearing protection are shocking.
This has been Cornell Racing's hit production of the Accumulator Inspection and Design Showcase. Thank you.
Thank you.
Point to it. Cool.